Alright, what's up everybody? Today we are looking at section 2.3 where we're going to apply our slope, midpoint, and length formulas. So we've already covered what all three are. You've known slope from grade 9 and we've done something in grade 10. We just covered midpoint and our length formula, which we also know as the distance formula. So let's go on. So we can see that we have the three different formulas here. Now, which is which? Can you guess which one goes with the slope formula? That's right. There you go. So that's slope. So that means the next one is midpoint, and finally the distance formula. Again, please make sure that you pay attention to the signs that are in each question, or sorry, in each formula. Alright, so remember the minus signs in the slope formula, the plus signs in the midpoint, and where the minus signs and the plus sign is in distance formula. Alright, so let's look at a problem that we have. A triangle has vertices D at 1, 4, E at negative 2, 2, and F at 3 and 1. So we're going to verify that these points form a right angle triangle. Now there's two ways to do this. One of the ways is to recognize that a right angle triangle has a right angle. And what do we know about right angles is that the slopes of the two lines would be negative reciprocals of each other. So that's one way to do it, is we can do it by looking at slopes, which we're going to talk about first. And the next thing we're going to do is we're going to talk about lengths. Okay, so maybe you can try and think about what we could possibly use to figure out using lengths. So let's start off with the slope. So what I've kind of done is I've already kind of set up, we're going to find out the slopes of DF first, then we're going to find out the slopes of EF, and then we're going to find out the slope of DE, and we're going to see what happens so that we can verify. So what I'm going to do is I'm going to solve all three of them. You can pause it right now and figure them out for yourself, and afterwards we will continue on with the lesson. So I've finished off the three slopes, so we can take a look. The first one, which was DF, alright, was this line right here, and the slope that I got was negative 3 over 2. You can check my points that I plugged in and just verify with yourself that you got the same answer. Now remember, if you decided to put the coordinates in the opposite way, meaning if you wanted to put the 1 in front where you did 1 minus 4, and then as long as you made sure that you got 3 minus 1, you would still end up getting the exact same answer. So that was DF. Then I checked out the slope of EF. So EF I got 1 over 5, which was this one right here. And then finally I did the slope of DE and DE right here, and I got the slope of 2 over 3. And if you notice that two of the slopes are negative reciprocals, and that is negative 3 over 2 and 2 over 3. And again, that is DF and DE. And you can even just see on the graph that it looks like that's where the right angle is. So the two slopes are negative reciprocals, and for that reason, we can say that this is a right angle triangle. Now, let's take a look at another way that we can do it as well, and we're going to do it with lengths. And when I think of lengths and a right angle triangle, as well as I'd like you guys to think about it, what comes to mind? If you said the Pythagorean theorem, c squared equals a squared plus b squared, then you would be correct. So what we're going to do is we're going to have to take a little bit of a long route, but we're going to find out the lengths of all three of these sides, and then we're going to see if it satisfies the Pythagorean theorem. Now, just by looking at the diagram, we can tell which one looks like it's going to be the hypotenuse, but let's do the work, and then we will make our conclusion. So I'm going to do it. Pause the video, you guys try it out, and then we'll continue from there. Alright, so it's all worked out, and we can see that DF, and I plugged in the formula, or I plugged in the coordinates for DF. I worked everything out, and I got square root 13. I then took a look at DE, I looked at EF, and I plugged everything in, and I ended up getting the square root of 26. And then finally I looked at DE, and I worked it all out, and I got the square root of 13. So now we've got the lengths of all three of the lines. So now we have to see is, does this fit the Pythagorean theorem? So again, our Pythagorean theorem, I'm just going to write it down again, is c squared equals a squared plus b squared. Or it could be the other way around, whatever. So let's plug it in. We've got the square root of 26 squared equals square root of 13 squared plus the square root of 13 squared. And if you guys are starting to see something, that is very, very good. So the square root and the squared, they end up canceling out. So we get 26 is equal to, these cancel out as well, 13 plus 13, 26 is equal to 26. And we can see that it has satisfied the Pythagorean theorem. Therefore, and I guess I'll just write everything down here. So this is for both, this is for the slopes as well as the length. Therefore, the points form a, and I'm just going to put here just for the heck of it, right angle triangle. Yay! That's great. Okay, so we're done one of the problems. Let's take a look at the next one. All right, so the next question we have is, given the triangle with points F 5, 10 and G 7, negative 6 and H 2, 5, find the length of the median from vertex H. All right, so do we have to find the slope? Do we have to get the y-intercept? The answer to that is no, because what is the question asking for? It is asking for the length of the median. But in order to find the median, we need a couple of things, right? Especially because it's coming from vertex H. If it's coming from vertex H, we need to find the midpoint of FG, and then we can find out the length. So I've got a little something here set up for us. Okay. And you can see right here, I want to find the midpoint of FG. All right. And I've kind of put everything here ready to go. And then after that, we're going to find the length, and you're going to find out what that length is yourself. So again, I am going to pause this, or I'm going to ask you to pause this. I'm going to ask you guys to try to work it out because everything has kind of already been given for you. And then we're going to continue going. So here we go. Our answers are 6 and 2. And I know that normally what I would ask you guys to do is to always make sure that you write your formula first, because that way when you're plugging in your values, you know that you've plugged them in correctly, you've got your signs correct, and you can continue with having the correct answers. Now, I know I haven't done it, but I'm going to ask you guys to make sure that you do it. So I put in as my x1 was 7, my x2 was 5. I add them together. 7 plus 5 is 12. 12 divided by 2 is 6. Then I made my y1 negative 6, plugged into there. My y2 was 10. Added them together, that gave me 4. Divided it by 2, and I get 2. And so when I look at it on my graph, at about 6 and 2, that looks correct about there. So now I have my median. At least I can draw my median from my midpoint to the vertex H, or vice versa, from vertex H to my midpoint. Now, all I want to do now is I need to find the distance. So I've kind of already set up the distance formula for you, and all you guys really have to do is just fill in the blanks. So why don't you guys do that? Pause it, fill in the blanks, work it out, and as soon as you guys hit play again, we'll have the answer. So there it is finished. So I just wrote down the midpoint here as well. I put the actual coordinates because that makes my life a little bit easier. And so I plugged in my stuff. So I did 6 minus 2 plus all squared plus 2 minus 5. I'm just trying to always stay consistent as much as I can, all squared. So do the math. You get 4 squared. 2 minus 5 is negative 3, all squared. So 4 squared is 16. Negative 3 squared is 9. Add them up equals to the square root of 25, which in the end equals 5. Fantastic. Boom, it's done. Now, if the answer is not an easy number to square root like 25, you can leave it under the square root and that will be the exact. But if you are going to round it, then I want you to either have an equal sign with a dot, or you can have an equal sign that kind of looks a little wavy. And that'll at least tell me that it is the approximate answer. So that's it. We're done. We've covered a couple of questions. Just make sure that you always know when to use the midpoint, the slope, and the distance formula. And anytime you use it, it will help you out to answer these problems. That's it for now, guys. Take care. Till next time, take it easy.